For this video, we are going to be looking at adding and subtracting fractions, and we're going to do some practice problems. We're actually going to be working from two separate companion assignments, so I'm going to do 4 problems, but I'm going to do numbers 1 and 2, and then number 1, and then another number 1. So if you're following along with the companion assignment, this will make perfect sense. If you are not, and you're just viewing this video for a little bit of extra practice or help, it may be a little bit confusing on the numbering. But we're just going to do a total of 4 practice problems, so you can kind of ignore the numbers if you don't have the companion assignment. So we're going to start with the first 2 problems. We're going to start with actually have a picture with them. So I'm going to draw the picture as well. Just give me a moment as I set this up. So 4/9 plus 1/3, that is our problem. And my diagram for 4/9. You'll forgive me, doing a 9th bar is a little bit challenging. 1, 2, 3, 4, 5, 6, 7, 8, 9. I want my boxes to be as close to the same size as possible. All right, so here's my 4/9. 1, 2, 3, 4 out of 9. And I'm going to add that to 1/3. All right, so when I'm doing this with a picture model, what I'm able to do is I'm just going to draw lines down to change my 1/3 fraction to change it to have a denominator of 9. Because remember, I cannot add this until my denominators are the same, until I have a common denominator. So what that changes to, 4/9 stays the same, because I haven't really changed anything on this one. But instead of 1/3 now, I have 1, 2, 3 out of 9. So my problem then reads 4/9 plus 3/9. Now just if we do the math on that, that's going to give us 7/9. If I count the actual blocks, that will also give me 7/9. I've got 1, 2, 3, 4, 5, 6, 7, and these are in ninths. Okay. Now, using this will only work with certain problems. If you get a problem that has the picture model set up this way, then it should work. But you can't necessarily do that with every problem where you're adding or subtracting unlike denominators. So we will look at how to do that in just a moment. All right, so number 2 is going to be 2/3 minus 1/6. Okay, so we got 2/3. We're going to subtract 1/6. Now, even though I'm subtracting, the process stays the same, although this time I'm going to draw my lines from the bottom because that's my larger denominator. So I'm going to draw my lines up. Remember, when you're doing this, your lines from the bottom should line up with some of the lines from the top. You shouldn't have just like a random line here off to the side. If you do, that there's probably some kind of an error there. All right, so what I'm going to end up with is this problem is going to change, and now instead of 2/3, I've got 1, 2, 3, 4 over 6. So this changes to 4/6. My 2/3 changes to 4/6, and then I'm going to subtract 1/6. And so what I end up with, if I just do the math first, is I end up with 3 over 6. All right, now if I look at my model here, I've got 1/6 here that I'm taking away. So I'm just going to take away 1/6 from the top, and I would get 1, 2, 3 out of 6. Now the other thing I need to do here is I need to, I can't leave just 3/6 as 3/6 because that answer is not in its simplest form. I need to find an equivalent fraction that is in its simplest form, because this fraction, as we can actually see from this model on the top, because here's my answer here now that I've taken away the 1/6, we can see that this this picture should look very, very familiar, because 3/6 is equivalent to 1/2. Now, if we didn't have the model, the way we could do that is we just divide both top and bottom by 3. And that gives us 1/2 as our equivalent fraction. All right, now we're going to switch gears a little bit, and we're going to switch to number 1 on one of the other companion assignments that goes with this, where we are adding fractions of unlike denominators, but we don't have a picture model to go with it, so we've just got the numbers. So we're going to have 1/2 plus 4/5. Now, sometimes when we do these problems, the denominators, we can very easily look at them and say, hey, like for example, if I did 1/2 plus 3/4, I could look at the 2 and the 4 and say, hey, 2 times 2 is 4, so I could just change this denominator to a 4, and of course I have to change my numerator as well. And then I don't have to do anything with 3/4. However, sometimes, like in the case of the problem we're on now, where there's not an easy way to do this just by looking at it. So one strategy is simply to multiply the denominators by each other. So if I take 1/2 and I multiply the denominator by 5, I'm going to get 10. If I multiply 4/5 and I multiply the denominator by 2, I'm going to get 10. Now remember, whatever I do to the bottom, I also have to do to the top. So I'm going to multiply the top by 5 as well. So I'm going to end up with 5/10. And so these two fractions, my 1/2 and my 5/10, those are equivalent to one another. Okay, let's do the same thing to the bottom. So again, I'm going to multiply whatever I multiplied the bottom, the denominator by, I must also multiply the numerator by. And so I end up with 8/10. And just as we did before, my 8/10 is equivalent to my 4/5. And that's all we've really done here, is we've just found equivalents for 1/2 and 4/5, so we can actually do the math. So my problem rewritten would be 5/10 plus 8/10, which will give me 13/10. Now this is an improper fraction, so that represents a problem for me. So I have to do a little bit more on this, because I can't leave it improper. I need to convert it to a mixed number. Remember, the way we do that is fractions, remember, are just a division problem in disguise. So what I'm going to do is I'm going to take this fraction, I'm going to turn it on its side, just like that, and then I'm going to do the division. Okay, so 10 goes into 13 one time. 1 times 10 is 10. You know what? I'm going to write this a little lower just so it's not all mashed up together. I want you to be able to very clearly see our answer. So remember, when I have a remainder, my remainder becomes my numerator, and whatever I'm dividing by becomes my denominator. So these two fractions are equivalent, or I should say this fraction and this mixed number, they are equivalent. And we can see, if I was to take 10 out of 13, I'd be left with 3 over 10, and my 10 over 10 would be my 1 whole. So this is my final answer. All right, let's do one more. And we're going to flip to the third companion assignment where we're actually subtracting without a model. So number 1 on that one is 1/3 minus 1/4. And again, for this, if I look at my denominators and I can't very easily see a common denominator, then I probably just want to multiply them by one another. That's going to be the easiest thing to do. So let's do 1/3, 1/4. I'm going to multiply my 3 by 4, my 4 by 3. And so 12 becomes my common denominator. And now I have to find out what my numerators are. So remember, whatever I do to the denominator, I must also do to the numerator. So I end up with 4/12. Same here. Whatever I've done to the denominator, I must now do to the numerator. And so I end up with 3/12. And so remember, what I'm doing here is I'm just creating equivalent fractions. The value of these fractions are the same, and the value of these fractions are the same. So then when I rewrite my problem, 1/3 becomes 4/12, and 1/4 becomes 3/12. And so my problem is 4/12 minus 3/12, which gives me 1/12. And this is my final answer.